Hello friends, today we'll learn how to write electronic configuration of an element. In your class 10th standard, you have learned to write the electronic configuration of element like 2, 8, 18 like that. But now you will be required to write down the electronic configuration in a more extensive way. For that, you will require to know the idea of 4 quantum numbers, which will give you the complete electronic configuration of an element. Those quantum numbers are known as principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Quantum numbers are actually nothing but combining all these 4 quantum numbers will give you the complete address of an electron in an element. As when we write our own address, what we write? First we write our name, then our house number, then street number, then our post office, then our district, then state, then country. Similarly, the principal quantum numbers will give you the number of orbit, number of orbital, and the number of subshell in which the electron is exactly present in the element. So basically we can say the quantum numbers in combination will give you the total address of an electron in an element. So now we will see the quantum numbers one by one. First is the principal quantum number. It is represented by the small n. It is nothing but the KLMN shells what you have learned already in your 10th standard. So it can have any positive integral values starting from 1. So if it is n is 1, that means it indicates the K shell. If it is 2, then it indicates L shell. If it is 3, then it indicates M, like that. Next important point is maximum number of electron in any shell or orbit is twice n square. For example, for n equal to 1 shell, maximum number of electron will be 2 into 1 square, that means 2. For n equal to 2 shell, maximum number of electron will be 2 into 2 square, that means 8. So now suppose you have got your country, the biggest one, which is given by PQN for the electron. Next we will come to azimuthal quantum number, and it is denoted by small l. So the country of electron is given by PQN. Now we will come to the state of the electron, suppose. So it gives idea about the subshell in which the electron is present. The important point to note down, for a given value of n, L also have total n values, and that vary from 0 to n minus 1. That means L should be less than 1. Now we are coming to the naming portion. As we have already seen, for n equal to 1 it is K shell, 2 it is L shell, like that. For L equal to 0 it is known as S subshell. For L equal to 1 it is known as P subshell. L equal to 2 it is D subshell. L equal to 3 it is F subshell. So now we are coming to a table. So this table gives you the idea how we can determine the values of L if we know the value of N. So there are 3 columns you can make: value of N, total values of L, that should be equal to N, and values of L, which will vary from 0 to n minus 1. So for value of n 1, total values of L will be 1, and it will vary from 0 to n minus 1, so that means it will be only 0. So how we can name this subshell then? 1s. 1 is coming from the value of n, and s is coming from the value of 0. Similarly, for value of n 2, total values of L will be 2, and it will vary from 0 to n minus 1. That means 2 minus 1, that is equal to 1. And how we can name it? For 0 it will be 2s, and for 1 it will be 2p. So if you are given a subshell like 2p, so what are the information you can know from this subshell? That means first information is that the shell is 2, that means value of n is 2, and value of L will be 1 because it is p. Similarly, for value of n3, we can have 3 subshells, 0, 1, 2, and those will be 3s, 3p, 3d. Suppose 3d, so what are the information you will be able to know? That means the value of n is 3 and value of L will be 2. Likewise, for 4 it will be 0, 1, 2, 3. So 4s, 4p for 1, 4d for 2, and 4f for 3. It is done in this way. So next we will come to the magnetic quantum number, MQN. It gives the idea about orientation of subshell and the number of orbitals in the given subshell. That means shell, then subshell, then you are coming to orbital, and subshell is also known as orbit. It is denoted by small m, and value of m depends upon value of L. And for a given value of L, m can have total twice L plus 1 values, ranging from minus L to plus L, including 0. That means total values will be twice L plus 1, and values are minus L to plus L, including 0. Again, we can see it from in a tabular form where we can write down, suppose value of L is 0, that means what? S subshell. Then total values of M will be 1, and it will vary. Since it is 1, so it will be only 0. Minus L to plus L, including 0. So if it is 0, that means it will be only 0. That means what? Only 1 orbital. Next we are coming to L equal to 1. L equal to 1. That means it is P subshell. So what will be the total value of N? That is twice L plus 1. 2 into 1 plus 1, that will be 3. So how it will vary? It will vary from minus L to plus L, including 0. Minus 1, 0, plus 1. That means there are 3 orbitals, minus 1, 0, plus 1. And we are writing it together. What does it mean? That means all these 3 orbitals are of equal energy. Similarly, for L equal to 2, that means it is D subshell. It will have 2 into 2 plus 1, that means 5, minus 2, minus 1, 0, plus 1, plus 2. It will vary from minus 2 to plus 2, including 0. That means how much? Total 5 orbitals of equal energy. Similarly, for L equal to 3, 2 into 3 plus 1, that means 7. So total of 7 orbitals of equal energy. Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So in this way we can get the total idea or the total address. Our next quantum number is spin quantum number, which is the 4th quantum number, and it is a little bit different from the other 3 quantum numbers, as it gives the idea of the spin of an electron. So basically we can understand from this figure this is the simplest model of the electron revolving in an orbital around the nucleus, positive nucleus. So while revolving around the nucleus, electron is also rotating about its own axis, like the rotation of Earth. So if this rotation is clockwise, then we can say arbitrarily that is the spin is plus half, and if this rotation is anti-clockwise, then we can say the spin is minus half. And for convenience, it is considered as upward spin plus half, and the minus half is considered as downward spin. So this spin quantum number is represented by small s, and it represents spin of electron around its own axis. So N, L, M, and finally S, all these 4 quantum numbers gives you the idea of the complete address of an electron in an element. Next we will learn how to write the electronic configuration and what are the information we can extract if we know the electronic configuration, and what are the rules to write down the electronic configuration which governs the filling up of electrons in the orbitals one by one. Before that, we will see a very small problem like this. Suppose it is asked, calculate total number of orbitals in the third shell. Third shell means n equal to 3. So now you are asked about the number of orbitals. So for n equal to 3, if we see manually what are the values of L, it can vary from 0 to n minus 1. That means what are those? 0, 1, 2. And now if we write the values of M depending on these values of L, we can have for 0 it is 0, for 1 it is minus 1, 0, plus 1, for 2 it is minus 2, minus 1, 0, plus 1, plus 2. So all total it will be how much? 9, isn't it? So manually we can calculate like this, but in another way how we can see, suppose not suppose, it is given that it is the third cell. That means what? N equal to 3. So as we have already seen, that is maximum number of electrons present in the n equal to 3 shell will be twice n square. That means 2 into 3 square. It means what? 18. Now one information that I have not given you, that one orbital can contain maximum 2 electrons. One is spin up and another is spin down. That is known as pairing of electron. Spin up, spin down. So if total number of electron is 18, so it will be accumulated in half of this. That means 9 orbitals, isn't it? So in this way we can find out, and which can be found out in a short way also. And from this we can formulate a formula where we can see total number of orbital will be simply n square. Means if it is 3, then orbital will be 3 square. If it is 4, then orbital will be 4 square. Like that. Next, another problem we will see where suppose you are asked which of the following set of quantum numbers are not possible. Set of quantum numbers. Suppose you are given this set. This set means what? N equal to 3. For n equal to 3, what are the subshells you will be getting? 3s, 3p, 3d. 3d means L equal to 2, but L cannot have the value of 3 when n equal to 3, because L should be less than n. It should be 0 to, it can vary only from 0 to n minus 1. That means 0 to 2 only, but cannot have L equal to 3. That means this set is not possible, and that we can say by looking only at these quantum numbers 2, n equal to 3. No need to go for m and s. Next set, if we see n equal to 4, then what are the values possible for L? It will be 0, 1, 2, 3. So it is okay, n equal to 4, L equal to 3. Next we are coming to m then. For L equal to 3, what are the values of m? It will vary from minus L to plus L including 0. That means from minus 3 to plus 3 including 0, where plus 4 is not possible. So this set is again not possible. Next we are coming to this set, n equal to 1, L equal to 0. It is okay. For 1, it can have only one value, that is 0. Now for L equal to 0, m will have only one value, that is 0. So plus 1 is not possible. Now we are coming to this set, n equal to 5, then L equal to 4 is possible, 0 to n minus 1. Now plus L to, m will have plus L to minus L including 0, so minus 4 is possible, but S cannot have value of 0. It can only have either plus half or minus half. So this set is again not possible. Next we are coming to this set, n equal to 6, L equal to 5, it is okay, 0 to n minus 1. L equal to 5, m equal to minus 5, it is okay, minus L to plus L including 0. Then S equal to plus half. Everything is fine, so this set is possible for an electron. So what will be this? And similarly for n equal to 7, L equal to 6 is possible, but m equal to minus 7 is not possible. Okay, next we are coming to another question, that is calculate value of n plus L for the following. N plus L. Suppose it is 1s. What are the values of n and L? Value of n is 1 and value of L is 0 for 1s. So what will be n plus L then? 1 plus 0, that means 1. For 2s it will be 2 plus 0, that is 2. For 3p it is 3 plus 1, that means 4. 5d it is 5 plus 2, that means 7. 6f it is 6 plus 3, that means 9. And 7s means 7 plus 0, it is 7. These are small questions like which quantum number cannot be fractional. So n, l, m, s can have fractional value, that is plus f minus f. Which quantum number cannot be 0? So n cannot be 0 and s cannot be 0. This is another question. Calculate total number of electrons having n plus l equal to 5. So for that you need to know the combinations which will have together n plus l equal to 5. Those combinations are 5s, 4p, 3d. So if it is 5s, that means 5 plus 0, that is 5. If it is 4p, then 4 plus 1, that is 5. If it is 3d, then 3 plus 2, that is again 5. 2 plus 3 is also 5, but if it is value of n is 2, so value of l cannot have 3 value. Now in 5s, total number of electron will be 2. Okay, so in 4p means there are 3 orbitals. So in one orbital, if it is 2 electrons, so total of in 3 orbitals it will be, total number of electrons will be 6. That means what? 4p means like this. P means m value will be minus 1, 0, plus 1. So in one orbital, total we can have 6 electrons. If it is 3d, d means five orbitals are present. Minus 2, minus 1, 0, plus 1, plus 2. So all total 10 electrons are possible. So what will be total electrons then? 18. So these are actually illustrations, but based on these calculations we can formulate some simple formula from where we can directly calculate this kind of questions. For example, maximum number of electrons in any orbit is twice n square. That is the first formula we learned. Now number of subshells in any orbit. Subshells, that means L. That will be n. Number of orbitals in any orbit will be n square. That I have already shown you in an illustration. Number of orbitals in one subshell will be twice L plus 1. Number of electrons in one subshell will be 2 into twice L plus 1. And number of electrons in any orbit or subshell in terms of L will be twice n square. And number of electrons in any orbit is 2. Maximum one orbital can accommodate 2 electrons. One is plus half, another is minus half. So based on this formula, we can do this problem. Suppose you are asked to calculate the following. Number of electrons in P shell. Just notice this point, P shell. That means what? That means you are asked about K, L, M, N, O, P. K shell, L shell, M shell, like that, P shell. So what will be the value of N for P shell then? It will be 6. So number of electrons will be 2n square, 2 into 6 square, that means 72. Next, number of electrons in P subshell will be. Now it is P subshell, that means L. You are asked about L. So it will be 2 into twice L plus 1. 2 into For P, L value is 1. So 2 into 1 plus 1. It will be 6. Number of electrons in P orbital. So if it is P orbital, what will be maximum number of electron? It can have maximum number of electron only 2. So these are clear? P shell, P subshell and P orbital. Next we are coming to number of subshells in P shell. It will be 6 because value of N is 6 in P shell. So value of L will have N values, that will be 6. Now number of orbitals in P shell will be 36 N square. This I have already given you the formula, and it can be solved with this illustration also. For N equal to 6, L will have 0, 1, 2, 3, 4, 5 values. 0 to N minus 1, that means. For L equal to 0, M will have 0 value. For L equal to 1, M will have 3, minus 1, 0, plus 1. For 2 it is minus 2, minus 1, 0, plus 1, plus 2, total 5. For 3 it is 7, for 4 it is 9, for 5 it is 11, total is 36. So this we can simply count by N square. So in this way we can do this kind of problems. Next we are coming to the most important point, that is rules for writing electronic configuration. What are the rules that govern this writing electronic configuration process? The first rule is Aufbau rule. Aufbau is a scientist who gave the idea that electrons are filled in increasing order of energy of orbitals. That means electrons are filled first in those orbitals which have lowest energy. Order of energy of orbital is decided by N plus L rule. Now what is this N plus L? Already we have seen, and it is required for multi-electron system, no doubt. So this N plus L rule already we have seen, that is value of N plus value of L. Again it is of two kind. First kind is that if N plus L is different. If two orbitals have different values of N plus L, then electrons are filled first in that orbital having lower value of N plus L. For example, you are asked about 1s and 2s. For 1s it is N plus L is 1. For 2s it is 2. So electron will first filled on 1s orbital, because energy of 1s is less than energy of 2s. Similarly for 2s 2p, value of N plus L is 2, value of N plus L is 3. So energy of 2s is less than 2p, so it will be filled first. If we compare 4s and 3d, so it is 4 and 5, so 4s will be filled first. This is N plus L. Second point is, if N plus L is same, if value of N plus L is same for two different orbitals, then electrons are filled first in that orbital having lower value of N. This is very important. For example, you are asked about 2p and 3s. For both 2p and 3s, N plus L value is 3. Now, where you will fill the electron first? You will fill the electron first in 2p orbital, because value of N is 2 here, where it is 3 in this case. So when the value of N plus L will be same for two different electrons, you will be required to see the value of N. Similarly for N plus L 5, there are 3 options, 4p, 5s, 3d. Among these 3, value of N is less for 3d, so it will be filled first, 3d, 4p, 5s. Similarly for N plus L equal to 7, there are 1, 2, 3, 4 orbitals are present, so 4f will be filled first, then 5d, 6p, then 7s. So this is the Aufbau rule. Aufbau and n plus l rule. Second, we will be coming to Hans rule, according to which pairing of electron does not take place unless each and every orbital contains single electron with same spin. This I can show you with an example. For example, suppose this is your L equal to 1, that means -1 0 plus 1 orbitals. Okay, now electron filling will be taking place like this. First it will be filled in this way. Once it is completely filled with 1 electron, only after that pairing will take place. That means what? Suppose you are given in configuration with P3. So it will be like this. P4. Once it is half filled, then pairing will occur. So this is all about Hans rule. If it is P2, it is simply, it will be like this. So pairing will occur only once all the orbitals have been filled with one or electron with the same spin. Next we are coming to the third rule for writing the electronic configuration, that is Pauli exclusion principle. So it simply says, according to this rule, no two electrons in any atom can have same set of all four quantum numbers. For example, for hydrogen atomic number is 1. That means what? 1 electron is present, so its electronic configuration will be 1s1. So it is filled up only in one orbital. So for this thing, n equal to 1, for n equal to 1, L will be equal to 0. So what will be M? For L equal to 0, M is again 0, S will be plus half. If it is helium, then its electronic configuration will be 1s2. That means what? Two electrons are paired up. So for these two electrons, what are the set of quantum numbers? N equal to 1, L equal to 0, M equal to 0, S equal to plus half. For the other electron, it will be, all these three quantum numbers will be same, but the fourth one will be different. So that is explained by Pauli exclusion principle. Now we are coming to the main point, that is writing the electronic configuration. Suppose we want to write the electronic configuration of sodium. For sodium, Z equal to 11. That means atomic number is 11. That means what? 11 electrons are present. So now we have to write down its electronic configuration. So we will start from shell number 1, that is 1s. 1s. For 1, the first shell orbital will be 1s. So total 11 electrons are present, so we have to fill it up. So 1s is the orbital having the lowest energy. Next to 1s will come 2s. For n equal to 1, only one orbital is present, that is 1s. For n equal to 2, two orbitals are present, 2s and 2p. Not orbitals, these are subshells, sorry. For 3, next will come 3. So for 3 subshells are present, that is 3s, 3p and 3d. Now we will fill up. So first we will fill 2 electrons in the 1s orbital, next 2 in the 2s orbital. 2p can accommodate total 6 electrons because it is p subshell 1, 2, 3, 4, 5, 6. How much? 2 plus 2 plus 6, that means 10 already have filled up. Next 1 is left, so it will be filled up in the 3s1. So what will be the configuration of sodium then? 1s2, 2s2, 2p6, 3s1. Similarly for magnesium, if we see Z equal to 12, it will be 1s2, 2s2, 2p6, 3s2. There is another way of writing this. We know the inert gas configuration, that is neon. Neon has Z equal to 10. So it will be 1s2, 2s2, 2p6. So for these electronic configurations, instead of writing all these things, simply we can write neon configuration up to 2p6 and then 3s1. For magnesium, neon configuration up to 2p6, then 3s2. This will tell you, that means magnesium. Sodium, magnesium, similarly aluminium, if we try Z equal to 13, then it will be neon. Neon means what? 2p6 and then 3s2. Next electron will enter then 3p. Next is our silicon, that is 14, neon, 3s2, 3p, 2. 3p can accommodate maximum 6. So it will be silicon Z equal to 14, neon, 3s2, 3p2. Phosphorus, it is neon, 3s2, 3p3. Sulfur, it will be neon, 3s2, 3p4. Chlorine, it will be neon, 3s2, 3p5. Finally, inert gas, argon, neon, 3s2, 3p6. Next we are coming to titanium. For titanium, Z equal to 22. So 1s2 to p6, 1s2, 2s2 to p6, 3s2, 3p6. That means what? Argon. 18 electrons have been filled already. Now 4 electrons are left to be filled up. So how will you fill it up? After 3p, what should come? 3d, 4s, like this. Now if we see n plus l, 3 plus 2, that means 5 for 3d, 4 plus 0, that means 4 for 4s. So 4s is having less number of n plus l, that is 4. So 4s will be filled up first, then 3d. That means 3p6, after that next 2 electrons will go to 4s2. 20, so next 2 will be 3d2. So for titanium, how we can write the electronic configuration? Argon 4s2 3d2. Similarly, if we see for manganese, Z equal to 25, then how we can write? Argon, that means already 18 electrons you have written. Next will be 4s2, that means 20. So how much left? 5 electrons are left. So D subshell can accommodate maximum of 10. -2, -1, 0, +1, +2. Maximum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't it? So D can accommodate maximum of 10. Now you need only to fill 5 electrons. So it will be 3d5. So manganese will be argon 4s2 3d5. Iron, if you write 26, it will be argon 4s2 3d6. Nickel, if you write Z equal to 28, it will be argon 4s2 3d8. Zinc, if you write Z equal to 30, it will be argon 4s2 3d10. This is the way how we can write the electronic configuration in an extensive way. I will show you 2 exceptions. One is chromium, another is copper. Now for chromium, Z is 24. So what it should be? Argon 4s2 and 3d4 ideally, but 3d4 means one, 2, 3, 4. But if I make it 3d5 somehow, it will be half filled. It will be completely half filled, isn't it? This is d4, this is d5. That's why this d5 arrangement is more stable than d4 arrangement, since it is completely half filled. So to attain this more stable arrangement or electronic configuration, it will be feeling like this. One electron of 4s orbital will jump to the 3d orbital and it will be argon 4s1 3d5 instead of 4s2 3d4 for chromium. And the second exception is copper, where Z equal to 29, and here also it will be 4s1 3d10. Ideally it should be 4s2 3d9, but since 3d10 configuration is the completely filled configuration, that's why it is more stable than the 3d9. So one of the 4s electron will simply jump to 3d orbital and the electron configuration will become argon 4s1 3d10 for copper. These are 2 exceptions. So this is the way how we can write the extensive electronic configuration of the elements. Thank you Students, I hope this tutorial will be very helpful in a basic understanding of electronic configuration of elements. Thank you.